Okay students, so let us now move on to the next section that contains integer type problems. Question number 43 says that if the maximum value of the function fx is equal to log of sine square a minus 2 cos a minus 3 by 2 to the base cos square x plus 4 sin x plus 12, where a and x belongs to real numbers, is lambda, then lambda raised to the power minus 4 is equal to. Okay, so students, we have a log term whose number is also variable in terms of a, whose base is also variable in terms of x. A particular function log of x to the base a is maximum when the number is maximum and the base is minimum. Okay, so this particular function log of this number will be maximum when sine square a minus 2 cos a minus 3 by 2 is maximum, and cos square x plus 4 sin x plus 12 is minimum. One more thing which we have to pay attention is the variable a and the variable x are independent. So sine square a minus 2 cos a minus 3 by 2, it will take independent values. Cos square x plus 4 sin x plus 12 will take independent values. We can analyze both the functions separately. Okay. So now I'll solve for the upper part. First of all, I have to maximize sine square a minus 2 cos a minus 3 by 2. That is 1 minus cos square a minus 2 cos a minus 3 by 2. That is minus cos square a plus 2 cos a plus 1 by 2. So I need 1 by 2 more in this bracket. That will be a negative half. So positive half gets added. 1 by 2 minus cos square a plus 2 cos a plus 1. So cos a plus 1 whole square. I need this quantity to be maximum. The maximum value will be when the perfect square goes 0. So the perfect square cos a plus 1 is 0 if cos a is equal to minus 1. So the maximum value is equal to 1 by 2. Now let us talk about the minimum value of this expression. It is 1 minus sine square x plus 4 sin x plus 12. That is 13 minus sine square x minus 4 sin x plus 4, and then outside again plus 4 because this 4 is of a negative sign. So this is 17 minus sin x minus 2 whole square. Now students, sin x minus 2 needs to be maximum in order to have this particular quantity minimum. Okay, so sin x minus 2 whole square, the maximum value can be minus 1 minus 2 whole square, that is 9. So 17 minus 9, it will be the minimum value of this expression. That is 17 minus 9, and that is equal to 8. What is the value of lambda? Lambda is log 1 by 2 to the base 8. 1 by 2 to the base 8. The answer is minus log 2 to the base 8, that is minus 1 upon log 8 to the base 2, that is minus 1 by 3. What do we need? We need lambda raised to the power minus 4. So lambda raised to the power minus 4 will be a positive quantity first of all because the power is even. Minus 1 by 3 raised to the power minus 4 will be 3 raised to the power 4, and the answer will be 81. So this is 81. Question number 43, the answer is equal to 81. Okay, let us move on to the next question, that is question number 44. Question number 44 says that if the equation x square minus lambda minus 3 of x plus lambda equals 0 has at least one negative root, then the number of non-negative integral values of lambda is. So let us draw all the possibilities if this particular equation has at least one root negative. So I'll draw the first case as, the first case will be exactly one root is negative, and the second case will be both roots are negative. Okay, so the first case, exactly one root is negative. There are two possibilities. This is the first possibility and this is the second possibility, where the second root is exactly 0 and one root is negative. For both the graphs, this condition holds. Over here, the second possibility is both roots are negative. So the graph has to look something like this. Okay. Now, for the first case, I will have d greater than equal to 0, first condition, then f of 0 less than equal to 0. Either it will be negative or it will be exactly equal to 0. I cannot comment on the vertex here, okay, because the vertex can be to the right of the origin as well. Over here, d greater than equal to 0 will be applicable, no doubt. F of 0 greater than 0, strictly greater than 0, then minus b by 2a less than 0. Obviously, in the second case, I have both the roots equal as well as negative. This is also the possibility, okay? Because it is saying that at least one root is negative. So now let us solve for d greater than equal to 0. D greater than equal to 0 will give me lambda minus 3 whole square minus 4 lambda greater than equal to 0. F of 0, lambda less than equal to 0. So this is lambda square minus 6 lambda minus 4 lambda, that is 10 lambda plus 9 greater than equal to 0. So this will give you lambda minus 1 into lambda minus 9 greater than equal to 0. This condition will be the same as this one. F of 0 greater than 0 will give me lambda positive. So minus b by 2 is negative. Minus b by 2 will be lambda minus 3 by 2. So lambda minus 3 by 2 is negative, means lambda is less than 3. Okay. From here I am going to get lambda belongs to minus infinity to 1 union 9 to infinity. Students, what we have to do finally, we have to take the intersection of the two conditions of case 1, intersection of the three conditions of case 2, and then we have to take the union, because both the cases are possible according to the condition of this question. Now what will happen here? Lambda belongs to minus infinity to 1 union 9 to infinity is the answer. Now let us see the intersection of the two conditions in the first part. So the intersection gives me lambda less than equal to 0. This is the answer of the first case. Second case, one condition, two conditions, three conditions. Lambda is greater than 0 and less than 3. That means lambda belongs to 0 to 1. Now students, what you have to do? You have to take the union of these two conditions which are present in the circle. So taking the union, I can say that lambda is less than equal to 1. The question is asking me the number of non-negative integral values of lambda is. Number of non-negative integral values are 0 and 1. So 2 is the answer. 0, 2 is what you are going to fill in the OMR. Okay. Let us move forward to question number 45. Question number 45 says that consider two sets. A set is the ordered pair x comma y such that mod x plus mod y equals 1 for all x y belongs to real number. Set B is ordered pair x comma y where mod x is equal to 1 and means intersection. Okay, so mod y equal to 1, intersection mod x equal to 1. Then the value of the number of elements in the power set of A intersection B is, where power set of x represent the power set of set x. So now let us try to draw the graph. The graph of the A set is quite easy. Mod x plus mod y equals 1. Students, whenever we encounter mod, we take the cases for that particular quantity to be positive or negative. In the first quadrant, both x and y are positive, so the answer will be a straight line, something like this. In the second quadrant, x is negative, so y minus x equal to 1. Third quadrant, both are negative, minus x minus y equal to 1. Fourth quadrant, y is negative, x minus y equal to 1. So this is set A in green color. All the points lying on this particular square, okay, are the elements of set A. Talking about set B, mod x equal to 1, that means x equal to plus minus 1, x equal to plus minus 1 are two lines which are parallel to y-axis and going through this particular point, because this point is 1, 0. This point is minus 1, 0. These are the two lines which are given as mod x equals 1. Mod y equal to 1 parallel to x-axis. Y equals 1 and y equals minus 1. Now students, you need intersection. Intersection of mod x equal to 1 and mod y equal to 1, that means the common points. This is the common point. 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 You know, these red lines can create a misconception. Now students, be very careful. Set B is only the set containing these 4 blue dots. It's not the set containing 2 red lines. So we must remove these red lines in order to avoid confusion. Okay. So removing these red lines, my A set 4 green lines, B set is 4 blue points. I can see that there is nothing common. So A intersection B is 5. N of A intersection B is 0. And N of power set of A intersection B is 2 raised to power 0, that is 1. 0, 1 is the final answer that you have to fill in the OMR sheet. Okay, let us move forward to question number 46. So moving on to question number 46, it says that the number of integral values of x belonging to the domain of the function fx is equal to log of 2x plus 99 minus x square to the base cos of pi x by 2 is. So students, we already know that the domain of fx equal to log x to the base a contains 3 conditions. The conditions are x has to be positive, that is the number, a has to be positive, and a is not equal to 1. So applying the condition of the base first, I can say that cos pi by 2x with mod is not equal to 1. Also it has to be positive. So cos pi x by 2 is not equal to 0 with a modulus sign. Because it cannot be negative, it lies between 0 to 1. So it can neither be 0 nor be 1. Cos pi x by 2 mod not equal to 1. Cos pi x by 2 not equal to plus minus 1. That means pi x by 2 not equal to n pi, where n is an integer. Okay. Students, this directly means that x is not equal to 2n. That means x cannot be a even integer. Okay. X cannot be even integer. Solving the second case, cos pi x by 2 non-zero, pi x by 2 not equal to 2m plus 1 pi by 2, where m belongs to integers. Directly I can see that x is not equal to 2m plus 1, where m belongs to integers. So if m belongs to integers, 2m plus 1 is an odd number always. X cannot be odd integer. Just solving the conditions of base, I conclude that x cannot be an even integer, x cannot be an odd integer. The question asks you the number of integral values of x belonging to the domain of the function fx is. The answer is 0, 0. Okay, so very simple question, just applying 2 conditions, we have got the answer. There is no possible integral values of x belonging to the domain of this function. Okay, let us move further to the next question. Okay students, so let us talk about question number 47. Consider a function fx equal to 5 cos of x minus pi by 3 plus 6 cos of x plus pi by 6 plus 3 sin of x minus pi by 3 minus sin of x plus pi by 6. Then the number of integers belonging to the range of fx is. We know that the range of a cos theta plus b sin theta lies from minus of under root of a square plus b square to plus under root of a square plus b square. So we have to combine the alike terms. Okay, what is the answer? So starting with this particular function, fx is equal to 5 cos of x minus pi by 3 plus 3 sin of x minus pi by 3 plus 6 cos of x plus pi by 6 minus sin of x plus pi by 6. Students, obviously we have two different arguments, x minus pi by 3 and x plus pi by 6, which are depending on the same variable, that is x. So we cannot directly apply the formula here. We have to first reduce it into a suitable form where we can apply the formula. Okay, so let us, one very nice observation about this question is that x minus pi by 3 and x plus pi by 6, the difference of these two angles is 90 degree. So if I put x minus pi by 3 as theta, I will get 5 cos theta plus 3 sin theta. There is no doubt in that this will be 6 cos of theta plus pi by 2, and this will be minus sin of theta plus pi by 2, because theta is x minus pi by 3. So f of theta, it becomes now simple substitution. x minus pi by 3 equals theta. This is 5 cos theta plus 3 sin theta minus 6 sin theta minus cos theta, which will give you ultimately 4 cos theta minus 3 sin theta. Now it is a single variable form f of theta. There is no other variable. 4 cos theta minus 3 sin theta, the range is minus under root of 4 square plus minus 3 whole square up to 4 square plus minus 3 whole square. So the answer of this particular question is range is minus 5 to 5, and I need the number of integers belonging to the range of fx, 5 negative integers, 5 positive integers, and then 0. So answer will come out to be equal to 11 integers. Question number 47, answer is 11. Okay, let us move forward to 48. Question number 48 says that the number of solutions of the equation 4 cos square x into sin x minus 2 sin square x equal to 3 sin x lying in the interval minus 2 pi to 2 pi open is. So let us convert cos square x as 1 minus sin square x, and the whole equation will be converted into sin x, and it will be a polynomial in sin x then. Okay, so writing cos square x as 1 minus sin square x, I have 4 into 1 minus sin square x into sin x minus 2 sin square x equal to 3 sin x. Let us put sin x as t. So this is 4t minus 4t cube minus 2t square equal to 3t. So ultimately I am going to get 4t cube plus 2t square minus t equals 0. Obviously sin x is t, and because sin x is t, only the roots lying between minus 1 to 1 of this particular equation are accepted, because that is the range of sin x. T is common, 4t square plus 2t minus 1. Either t is equal to 0 or t is equal to minus 2 plus minus under root of 4 plus 16, that is 20, divided by 8. Minus 2 minus root 20 divided by 8 and minus 2 plus root 20 divided by 8, both these values are lying in minus 1 to 1. Okay, so let us say t equal to alpha and t equal to beta. Both these values lie in this particular interval. Okay, we can easily calculate the approximate values. Now we need the number of solutions in minus 2 pi to 2 pi. So let us plot the graph. So this is the graph. We have two distinct values. One is a positive value lying between 0 to 1. How many solutions it is going to give? 4 solutions. One negative value lying in minus 1 to 0, 4 solutions. Sin x equal to 0, 3 more solutions. Total number of solutions is 11. Question number 48. The answer is again 11. Okay, 11 number. Let us move forward to 49. Question number 49 says that the number of integral values of lambda for which the complex number lambda cube plus iota minus 4 lambda square minus 18 iota lambda plus 2 minus 175 iota, where iota is under root of minus 1, has negative principal argument. Students, it is a very easy question. A given complex number has negative principal argument if it is lying either in the fourth quadrant or in the third quadrant. That means the imaginary part of this number, the y part of x plus iota y, has to be negative. That is the only condition which is need to be applied. So imaginary part of z has to be negative. So this is real. Lambda square from the second term, 18 lambda from the third term, and minus 175 from the last term. Very easy one. 25 and 7 less than 0. It is strictly less than 0, mind you. Minus 7 to 25. 6 values on the negative side. 1 is 0 and 24 values on the positive side. The number of integral values of lambda satisfying the condition of the question is equal to 31. Question number 49, answer is 3131. So let us move on to question number 50. Question number 50 says that if the complex number z1, z2, z3 and z4 are the roots of the equation z power 4 plus z cube plus 2z square plus z plus 1 equals 0, then the value of z1 power 4 plus z2 power 4 plus z3 power 4 plus z4 power 4 is. Now students, this is a biquadratic equation. z1, z2, z3, z4 are the roots. Factorization is the only possible way. Okay, so z power 4 plus z cube plus 2z square plus z plus 1. So we have to smartly factorize. I'll take 1 z square with z power 4, 1 z square with 1 and 1 z cube with z. So these are the pairs which will be giving me some factors common. Okay, so you have to carefully select them. Take out z square common. Inside I have z square plus 1. This is z square plus 1 into 1. Simple. This is z into z square plus 1. So z square plus 1 is common throughout. If z square plus 1 is common, we have z square plus z plus 1 equal to 0. We know that roots of the equation z square plus z plus 1 equal to 0 are z equal to omega and z equal to omega square. Z square plus 1 equal to 0. The roots are iota and minus iota. So just by factorization, we are able to find out all the 4 roots. Iota power 4 will be 1. Minus iota power 4 will be 1. Omega power 4 will be omega power 4. Omega square power 4 will be omega power 8. I need the modulus of this. So 1 plus 1 plus omega power 4 is omega. Omega power 8 is omega square. Omega plus omega square, it is minus 1. So 2 minus 1, the answer is 1. 0, 1 is what you are going to fill in the OMR. Okay, the first natural number. Okay, so let us move on to the next section of this paper now.